Welcome back. Let's go through a bit of a history lesson. You know how much I love those. It's always important to ask, why did this tool get built? Why did people spend time and money creating it with any tools that we use? So before we had Docker, we had something called virtualized machines, and that is over here on the left-hand side. We had tools like VMware or VirtualBox. And virtual machines are what we call sandboxed environments, which contains a full-fledged computer with its virtual hardware, operating system, kernel, software. And as you can see in this diagram, it's like having, if you can imagine this being one computer, a virtual machine was like having another computer on top of it. So you had app 1 running on an operating system on this computer, app 2 running on the same computer, but again, another operating system. And you can see it was pretty big, but this allowed us to solve this problem of having things run in an environment, that is the blue environment here, the orange environment, the red environment, in a consistent, predictable manner. And because there were such big things that had their own operating system and libraries, that sometimes it took a few minutes to even boot up these applications. Now, Docker came along and changed the idea a bit. You see, with Docker containers, they wrap up the software in a complete file system that contains everything it needs to run. Just like we had with virtual machines. You had code, runtime, system tools, system libraries. Anything that you could install on a server, you can use with Docker. And again, this guaranteed that it will always run the same regardless of the environment it is running in. Now, containers are a lightweight alternative to the full machine virtualization or virtual machines. Therefore, they're designed, unlike virtual machines, for running just single applications on each container because they're so small and thin. And this is a popular concept of microservices that we talked about. Containers use the host's operating system. They don't have their own operating system like we have with virtual machines. They use the host's operating system. And because of that, they need just a few seconds and your container application is up and running a lot faster than we had with virtual machines. So with Docker containers, we're able to have fast and easy access to run these small single applications and just have multiple of these things. Just create as many containers as you want. They're easy to just grow and grow as you scale, as you have more users. And that's when you start getting into things like container orchestration, where you now have to just manage all these containers. Which, by the way, if you have ever heard of Kubernetes, that is what it does. So I think we got that point across. Docker is a container platform. Unlike virtual machines, containers bundle only the libraries and settings required for your application. They're efficient, lightweight, and self-contained. And this makes sure that your application will run the same anywhere and everywhere. So containers are good, right? Absolutely. Now that we got that across, let's talk about what containers actually are. I've kind of thrown around that word, but haven't really explained what it is. Well, a container can be explained with this diagram. We first have a host. That is a machine or a computer that we're going to be able to host our container on. So again, in this section, we're going to use our laptop as the host or your computer as the host. Now, on top of this host, we have what we call the container, something that we create with Docker. And luckily for us, with one command, because of Docker, we can just create this container. And inside of it, we have something called an image. And a container consists of an image. You see, an image is what Docker uses to bundle your application into a standalone package that can live inside of a container. So within this image, I could say I want a node server, and this image is read by the Docker because, again, it's just a file. And this file generates this container that runs Node for us. Now, the key part of this is that the environment inside the container is completely isolated from that of the host machine. So it doesn't matter what we run here, as long as this machine can run Docker, then within this container, we can have all the libraries and dependencies that we want for our Node server to work. And by the way, this image also has something called a writable file system, just like we have files on our computer, and is added on by Docker automatically inside of this container, and that's what we call a volume. So we have the image, which is the file that describes what the container should do, and within the container, we also have the option to use something like a file system, just like we have files on our laptop, for extra functionality. To review, Docker bundles your application into an image, a standalone executable package, and Docker executes this image in this container. And the environment inside the container is completely isolated from that of the host machine. Again, this is something that we're going to come back to. I'm going to demonstrate to you how we're going to do this, and we're going to work together to create a Docker container. And then we're going to come back to this image, and you're going to realize, oh yeah, this all makes sense now. So stick with me, trust me, you're going to get it. Now, this whole image thing sounds pretty complicated, right? Well, luckily for you, there's something called Docker Hub, and it's what makes Docker an amazing product. You see, Docker Hub, simply hub.docker.com, is kind of like NPM in JavaScript land. With Docker Hub, it provides a store-like website where you can search and download images to use that were already pre-written by people. And it's highly adopted by a lot of people and many organizations, so it's something that most people working with Docker use. For example, if I scroll down, I see that, all right, there's a node image that I can use. If I click on details, I see that, all right, I have different node versions that I can use. Let's say I want to use 9.11. I can click on the Docker file here, and look at that. Although this may look like gibberish now, we're going to go over this a bit in later on videos, but this is the Docker image. By just using this file and running Docker with it, it's going to create a container that has the node version 9 already set up for us. And you can see here that we have plenty of things that we can run. We can run Postgres, we can run Mongo, we can run Ubuntu, Redis, which we're going to talk about, and so many things. So just like NPM, you can use these packages already predefined for us. And most of the time, you're going to be doing that instead of writing your own. But I'm going to show you how to write some of your own Docker files, because why not? So now that we have the basic understanding of what Docker does and what containers are, in the rest of the section, we're going to be doing something like this. In our development setup, we're going to create a Docker container that is connected to our front end SmartBrain application. Now, within this Docker container, we already have our Node Express API, but we're also going to bring in our Postgres, as well as eventually Redis for session management, again, coming up in future sections. And by putting all of this in a container, we can just run one single command and have the database, API server, Redis database all running, getting started, getting booted, and starting together in this one container. It's going to be like magic. And by the way, in most production setups that you see with modern companies, you'll see something like this, where you have our client-side application, our SmartBrain, that has some sort of a load balancer. And this load balancer just distributes to different API servers so that if we have a lot of traffic, we don't clog up one API server. And we have these API servers cloned because they're just simple Docker images. So by just creating more and more containers, that's easy for us to do. And don't worry, I'll show you how to do a load balancer as well in an upcoming video. And these API servers now connect to databases like Postgres, and we can have multiple databases again to handle all the load. And also they can connect to something like Redis, which we'll talk about, that manages caching or session management. And you can see by having Docker, we're just able to easily clone and create more copies as we scale and as we grow. But I wanted to show you this diagram just for reference to show you what a production app looks like. The idea being that we're able to create these small services that we can duplicate so that as our demand of the app grows, as our user base grows, we can grow with it. All right, it's time to get started with Docker in the next videos. I'll see you in that one. Bye-bye.